Today we're going to be talking about physical and chemical properties. Now the last time we met, we talked about the difference between elements and compounds compared with mixtures. And we said that elements and compounds were pure substances and that compounds could be separated into smaller parts, but it took a chemical reaction or a chemical change. And we said mixtures could be separated physically. Well, I want to give you a little more insight on what that means today. And what we can do, how we can tell different kinds of matter apart, are through physical and chemical properties. A physical property is something that you can observe without changing the identity of a substance. You can tell this jacket's pink, you can tell this countertop is cold, you can find the mass of something and not change its identity. All of those are examples of physical properties. A chemical property, on the other hand, is one that you test, you risk changing the identity. If you want to see if something's flammable, you've got to risk setting it on fire. If you want to see if something reacts with an acid, you have to risk reacting it with acid. So we've got physical properties, which have no danger to test, and chemical properties, which you risk the identity of the substance. Now, how can we tell physical properties? There are a lot of physical properties. Odor is one. You can smell something and not change its identity. Flammability would be a good example of a chemical property. Some that fall into these categories that are a little confusing, we'll talk about when we break these down specifically. But with physical properties, things like solubility or dissolvability, if you will, falls into this category. If you're testing rocks and minerals, hardness falls into this category. Density. We can find the density of something and not risk its identity. So all of those are examples. Anytime you see reactivity, that's a sign you're talking about a chemical property. Reactivity leads you to think chemical reaction. Now, boiling water is a physical property, or the boiling point of a substance is a physical property. Okay? Now, when we boil water, we're physically changing it from one phase of matter to another. Physical change and physical property differ. A physical change is a transformation, often from one state of matter to another. For instance, in a physical change, you do not change the identity of a substance. So here, I have glass. Can you see that?
Yeah.
Okay. I'm going to use this file. I'm going to score the glass. Now, by scoring the glass, I've put a little bitty mark on the glass. That doesn't change the identity of the substance. It's a physical change. I'm now going to break the glass. I've changed it physically, but it's still the same stuff. It still has the same identity. Now, I'm going to use heat and do a little bit of phase changing with the glass. And its look will be different, but it'll still be the same thing, the same property. Gas is on, gas is on, gas is on. Okay. Now I'm going to heat the glass, get those molecules excited. This is not your normal glass. This is a sodium glass, and you'll notice the top of the flame is looking orange. Okay? And it's starting to bend. Normal glass won't bend at this low temperature, but I made it a liquid. Okay. Now it's cooling off. It's turning back into a solid. It's still the same material. It's still exactly what it was before. So that's an example of a physical change. We've changed the look, but it's still the same. If something shatters, it's still the same material that we started with. That's a physical change. chemical change, on the other hand, is more like what we saw at the end of class. When I took you outside and we mixed all those compounds together, we added water and we saw fire. That's something that's different. It's no longer what it was. Okay? We've got to have a chemical reaction or a chemical change to make new substances. Chemical change is the same as chemical reaction. Now, I'm a lazy chemist, so often I will abbreviate reaction as RXN. That's the chemistry abbreviation for reaction. Now, what are signs that a chemical reaction is taking place? Well, you might see the formation of a gas, which is bubbling. Now, don't confuse this with boiling a substance and just changing that same substance into its same gas. This is if you mix two chemicals and suddenly some bubbling occurs. Okay. Another thing you might notice is a temperature change. Okay? Now, again, I'm not saying put it on a hot plate and it gets warm. That's a given. But if you mix two room temperature chemicals together and it gets cold, or you mix two room temperatures together and they produce heat, that's a sign of a chemical reaction. Also, you might see a color change. Now, don't confuse this with diluting something. If you have red Kool-Aid and you add a gallon of water to it, it's going to turn pink. Okay, but that's not the color change we're looking for. This is like if you start with something clear and it turns blue, or if you start with something pink and it ends up green. We're talking a real color change here. And the last one you might see is the formation of a precipitate. Abbreviated PPT. I know, that's like PowerPoint, but it's different in chemistry. And we're going to look and see what that is in just a second. Something you won't see, but you might observe, is odor. A lot of chemical reactions have odor. Okay. So let's look at some examples of some chemical changes. I guess I'll do these down here. Would that be good?
Yeah, sure.
Okay. This is zinc. Put some in this test tube. And to it, I'm going to add some hydrochloric acid. And right away, you notice there's bubbling. This is very exothermic, or very warm. It's producing a lot of heat. And you'll notice there's vapors coming off the top. I'm going to try to trap some of these vapors for a second. No, I'm not that cool. And we're going to try to ignite this gas and make yet another chemical change. Okay. If you heard that, and if you look very closely, now you see the formation of liquid here at the top. The gas that was being produced is hydrogen gas. So that was one chemical reaction. The zinc and the hydrochloric acid made hydrogen gas. Then when I introduced the flame, that's adding oxygen to the hydrogen. So therefore this liquid, we actually just made water in that chemical reaction. So here we've seen bubbling. We've seen a temperature change. And if you were with us, you'd notice a small odor. The formation of a precipitate in a color change, I want to show you a different example of. A precipitate is when we start with two clear liquids and seemingly out of nowhere, a solid forms. Here's potassium iodide. As you can see, it's a nice clear liquid. Here's lead nitrate. Hopefully you can also tell that's clear. And I'm going to mix these two together and see if we get signs of a chemical change. 1, 2, 3, bottoms up. Oh! Notice right away, hopefully, that we got a color change. Now this is a much thicker consistency than what we started with. And I don't know, can you zoom in on that?
Yeah.
Can you see the powdery stuff forming at the bottom?
And you can definitely
There's
see on
some
the glass.
chunky stuff forming at the bottom. That chunky stuff is our precipitate. That's a sign of a chemical reaction. We had two clear liquids and all of a sudden something solid forms out of nowhere. So this is an example of a color change, and this is also an example of a precipitate. Chemical change. Let me double check the notes and see if there's anything else I need to tell you about this part. Really not so much. So that is the first part of your notes, and I hope you enjoyed it. Happy studying.